Solving rational equations. We have a couple of steps listed out up here for you on the top of your note sheet to follow along if you need them for solving rational equations. But let's go ahead and see if we can use our prior knowledge of rational expressions and solving equations to kind of logic our way through these problems. Okay, so let's look at this first example. It says 6 divided by 5x equals positive 4. Now, hopefully you remember from your pre-algebra days that when you have one fraction equal to another fraction, and I can turn the number 4 into a fraction by putting it over 1, this is just a proportion. And to solve a proportion, all we need to do is cross multiply. So we multiply in one direction and then in the other direction and set those values equal to each other. So 5x times 4 just gives us 20x. And that should equal 6 times 1, which is just 6. And then to solve for x, we just divide both sides of our equation by 20. And we get x equals 6/20ths, right? Well, 6/20ths we can reduce, definitely. 6 and 20 are both divisible by the number 2. So when I divide 6 by 2, I get 3. And when I divide 20 by 2, I get 10. So x just equals 3/10. Now, anytime you have a rational equation, you've got to know that we have some domain restrictions. What's a domain restriction? Well, that's a value that your x can never equal. Something your x value can never equal. So look at your denominators. You're never allowed to divide by 0. And right now we have this 5x in our denominator. So you might want to start with domain restrictions every time you solve one of these rational equations. We know that 5x is not allowed to equal 0. Well, how do you isolate that x variable? You just divide both sides by 5, and we get x cannot equal 0. This is our domain restriction. But because we only got 3/10 as our solution, I don't have to worry about that domain restriction for this problem. But you do always need to check it just to be sure. Okay, second problem. We have another proportion. We have two fractions that are equal to each other. So I go ahead and say, all right, I'm going to cross multiply to solve this proportion. Again, that's two fractions that are equal to each other. So and you can multiply either direction first, it doesn't matter. We have 5 times x minus 5, and that should equal 10 times x plus 3. So I'm going to go ahead and distribute, and we get 5 times x, which is 5x. Well, let's use red. 5x. And then 5 times our minus 5 gives us minus 25. And that should equal 10x plus 30. So we have this linear equation to solve. All we need to do is get all of our variables on the left side and our constants on the right side. So I'll subtract 10x from both sides of this equation. And that gives us negative 5x minus 25 equals 30. And let's move the constants over to the right side. So I'll add 25 to both sides of this equation. And that gives us negative 5x equals 55. And so to isolate x, we just need to divide both sides by negative 5. And that gives us x equals negative 11. Now again, I need to make sure that this is not a domain restriction. We need to make sure it's not an extraneous solution. So if I look at my denominators, x minus 5 is not allowed to equal 0. And to isolate that x value, we just add 5 to both sides. So x can't equal 5. So far, so good. And then I also had a denominator of x plus 3 that's not allowed to equal 0. So subtract 3 from both sides of our equation, and x is not allowed to equal a negative 3. So neither of those domain restrictions applies to the solution that I found. So negative 11 is a valid solution. All right, let's try some more. We have, this problem is a little bit more involved, okay? I still have a proportion because, again, it's one fraction over another fraction, or equal to another fraction, excuse me. So when I look at these two problems, I can see that this denominator is not in factored form. So I want to go ahead and factor this just to see what I have. I know that I can divide out a -3 from both of these terms and an x variable. So let's do that. If I divide out a -3x, I'm left with x minus 6. Okay, let's go ahead and check our domain restrictions just so we don't forget later. I know that x plus 6, our first denominator, is not allowed to equal 0. So x plus 6 cannot equal 0. When we isolate x, we get x cannot equal -6. That's my first restriction. Then I have this second denominator right here, but it's got two factors in it. So -3x is not allowed to equal 0, nor is x minus 6. So that's two separate equations that I need to set up, or non-equations. So -3x is not allowed to equal 0, and x minus 6 is not allowed to equal 0. And when I divide both sides of this equation by a -3, I still get x cannot equal 0. So that's another restriction. And then when I add 6 to both sides, I get x cannot equal 6. So those are my three domain restrictions. Now, I've got my two fractions, my proportions that are equal to each other. So I'm just going to cross multiply in both directions. And again, it doesn't matter which way you multiply first. So if we start out, we have x plus 6 times x minus 6, and that should equal, when I multiply this way, 2 times -3x will give me a -6x times that x minus 6. Now take a look at this equation, and hopefully you recognize that you have the same factor on both sides of our equation. So I could essentially divide out the x minus 6 from both sides and keep my equation balanced. Okay, so I'm going to divide this side of my equation by x minus 6, and I can divide this side by x minus 6. Both of those will simplify out, and we're left with x plus 6 equals -6x. Now I want you to be careful with this step. The only time that you're allowed to divide out these common factors from both sides of your equations are when they come from your denominator. Because this x minus 6 is found in one of my denominators, that's why it's okay for me to go ahead and divide it out. If you divide out something that comes from your numerators, it could be a problem. You might be throwing out a factor that would help you find a valid solution. So just be careful that you're only dividing out values or factors that come from your denominators, okay? So we have x plus 6 equals -6x, and that's a lot easier to solve than this quadratic equation that we were going to have. All right, so let's get all of our x variables on one side. So I'll go ahead and subtract x from both sides of my equation. And that gives me 6 equals -7x. And then I can divide both sides by -7. And that gives me x equals -6/7. Now I look at all of my domain restrictions, and again, -6/7 is not one of them. So this is a valid solution. Now you might feel like this is a lot of work to do in order to find only one solution, and that is okay. You are capable of doing difficult things. You are capable of taking all of this information that you already know how to manipulate and use and applying it to one problem. But let me show you how you can use Desmos to help validate your answer. So if you go to a Desmos calculator, I can look at this problem right here. I graphed the left side of my equation in my first function and the right side of my equation in the second function. And I can see that they intersect in one spot right here in the center of my graph. So when I click on that value, I see that the x value is a -0.85714, keeps going. So what did we get for our answer? Well, we got -6/7. And if you just type that into your Desmos calculator, it shows you the exact same decimal, right? the x variable or the x coordinate of that intersection and -6/7. Those are the exact same non-terminating decimal. That's how we know we did our algebra correctly. And if there were any other intersections, those would also be solutions. But because there are no other intersections, that was our only solution for this problem. Okay? Let's try another one. So again, I have two fractions that are equal to each other. So this is a proportion. Our domain restrictions would be x plus 2 cannot equal 0. So x is not allowed to be -2. That's one restriction. And we also have x minus 4 cannot equal 0. So x cannot equal a positive 4. We have two restrictions for this problem. So I'll cross multiply to solve this proportion, and we get x plus 2 times x minus 7, x minus 7 should equal x minus 3 times x minus 4. And when I look at this equation, there are no common factors on either side, so I can't simplify that down. I'm going to have to go ahead and double distribute. Now, if you like using the box method to multiply your two binomials together, then go ahead and do so. I'm just going to double distribute, okay? So we've got x squared minus 7x plus 2x minus 14. And all of that should equal x squared minus 4x minus 3x plus 12. So we've distributed that out. We don't have any more parentheses, so we can solve this equation. I forgot a squared term. So sorry. X times x gives us x squared right there. Okay, so let's combine our like terms. I see that I have a -7x and a plus 2x right here. So that gives me a -5x. We'll go ahead and bring down our x squared and our minus 14. And all of that should equal x squared. And again, we have like terms. So I'll combine those together to get -7x and then bring down our plus 12. So I've got this equation. It's a quadratic at this point. Or at least it looks like one. So let's go ahead and combine our x squared variables. If I subtract x squared from both sides of my equation, look what happens. X squared minus x squared is 0. Those cancel each other out. So I'm left with -5x minus 14 equals, and again, x squared minus x squared cancels to 0 again. So I'm left with -7x plus 12. This is now just a linear equation. So let's get all of our x variables on one side. So I'll add 7x to both sides. And that gives us 2x minus 14 equals 12. And then we can add 14 to both sides of our equation. And that gives us, let's go right here, 2x equals 26. And then, of course, I can just divide both sides of my equation by 2 to get x equals 13. Now, if you don't like using Desmos, or if you don't like necessarily checking the graph, you would rather try the algebraic way of checking, let's just take our solution, which, by the way, was not a domain restriction in either instance, and let's substitute it back into the original equation. So every time I see an x, I plug in the number 13. 13 minus 3 gives me 10. And 13 plus 2 gives me 15. 13 minus 7 gives me 6. And 13 minus 4 gives me 9. So 10/15 should equal 6/9. Well, 6/9 does reduce to 2/3. And 10/15 does also reduce to 2/3. So we know we did our algebra correctly that way, if you can substitute your value in and make your equation true. All right, last problem, and this one's going to be a little bit more involved, which is just fine, because I don't have a proportion in this problem right now. I have two fractions on the left side of my equation. So I need to combine those two together right now. So x minus 4 and x minus 2. To get our common denominator, we just need to multiply We'll multiply the first denominator by x minus 2, and we can multiply the second denominator by x minus 4. And now they have a common denominator. But do not forget that your fraction is not balanced right now. So whatever we've multiplied our denominator by, we need to multiply the numerator by also. So we'll do the same thing with this fraction over here, x minus 4. Okay? So this first fraction on the left ends up being x minus 2 divided by x minus 2 times x minus 4. Whoops. Well, maybe I can use these tools. X minus 2 times x minus 4. And then we'll add to that. X times x gives us x squared. X times that minus 4 gives us a minus 4x over x minus 2 times x minus 4. And all of that should equal 2. And then I see that I have this other big denominator right here, x squared minus 6x plus 8. But these denominators are already factored, so let's go ahead and factor this also, okay? Because our leading coefficient is a 1, what are the factors of positive 8 that combine to give me a negative 6? Well, 8 is just 4 times 2, but that doesn't give me a negative 6. So if I multiply by negative 4 times negative 2, those will add to give me a negative 6. So our factors are going to be x minus 4 times x minus 2. X minus 4 times x minus 2. Okay? So now let's add the left side of our equation. Because we've got common denominators here, we can add our numerators together. So this numerator becomes x squared. I see that we have an x and a minus 4x, so that's going to be minus 3x. And then we also have a minus 2 right there. And all of that is being divided by x minus 2 times x minus 4, which should equal x minus 4 times x minus 2 in our denominator, and 2 is in our numerator. It's really important that you keep your equation balanced at every step. You don't want to take any shortcuts just because you're tired of writing things down, okay? Make sure you keep every single step balanced. Now, what do you notice about this step in our equation? Hopefully you see that both of your denominators are exactly the same. So if you have two fractions with the exact same denominator, that has to mean that your numerators are equal to each other also. You're more than welcome to solve this problem by cross-multiplying like you have been. But if you recognize this, then you can just say, oh, well, x squared minus 3x minus 2 has to equal 2. My numerators have to equal one another. And how do we solve a quadratic? We just set it equal to 0. So I'll go ahead and subtract this 2 from both sides of the equation. And that gives us x squared minus 3x minus 4 equals 0. And the factors of negative 4 that combine to make a negative 3 are a negative 4 and a positive 1, right? And if I have two factors that multiply to make 0, that means either x minus 4 has to equal 0 or x plus 1 has to equal 0. So when I solve each of those for x, I get x equals positive 4 and x equals negative 1. Now, before I say that I'm finished and that I have two solutions, again, we always have to check for our extraneous solutions. So go back to your original problem. We have our first denominator of x minus 4 that's not allowed to equal 0. And when we isolate that x value, we get x cannot equal 4. And then we have our second denominator that's not allowed to equal 0, this x minus 2. So x minus 2 cannot equal 0. And to isolate that x, we just add 2. So x cannot equal positive 2. We have x cannot equal positive 4 and x cannot equal positive 2. And we have this denominator right here. But this denominator in factored form is this, x minus 4 and x minus 2. And because we've already used those two factors in our domain restrictions, we don't have to do them a second time. We're going to get the exact same restrictions. So 4 and 2 are the only values that are not allowed to be solutions. And if I look down here, x equals 4 was one of the solutions that I got. So this right here we have to throw out. It's called our extraneous solution. It's an extraneous solution. It's a solution that we got that makes our denominator false. It's not going to work because it makes one of the denominators 0. It makes our equation false because it makes our denominator 0. So the only solution we have is x equals positive 1. Now again, I know this is a lot to remember, but all of these steps you've learned in pieces. You already know how to add and subtract fractions. You already know how to multiply rational functions and find common denominators and solve. So we're just putting it all together now. Don't try and rush through your work, just take it step by step. You got this.